So for the purposes of discussing equilibriums and Le Chatelier's principle, I want to make up an analogy. One single boy plus one single girl makes a dancing couple at the middle school dance. Except it's middle school, so they can break up. Or they will break up a lot. And eventually, if you give them, half an hour or something, you'll get a situation where they break up just as fast as they form, and you'll get an equilibrium. And if you look back at any one time, let's say there are 20 dancing couples at any one time. It's not always the same 20, but it'll be 20-ish at any given point. And that's an equilibrium when they break up just as fast as they form, and these rates are equal. But then we can stress the system. And so the boys' Catholic school bus pulls up and dumps out more single boys. And so that's my cause. I'm just labeling it cause and effect for our purposes. You don't actually have to do that in your work if you don't want to. So if the number of single boys goes up, that makes more opportunity for the girls to meet somebody. And what happens to the number of couples? Does it go up, down, or stay the same? And it would help to have some interaction. Anela, what do you think?
It'll go up.
Yeah, it'll go up. So the effects here, I'm putting E for effect, is that the couples will go up. And another way to say that is the system will shift to the right. The rate of couples forming for the next 2 minutes or something will be greater than the couples breaking up. And so the system will shift to the right. And when we look back in 5 minutes, we won't have 20 dancing couples, we'll have 27 or something. And that means then that the number of single girls in the end will have gone what? Carol?
Go down.
Yeah, it'll go down. Because we'll use them up making couples, right? So another way to say this is, when I gave this thing extra boys, I made the left side the strong side. And if you look at here, the first rule is the system will shift toward the weaker side and away from the strong side. So if I put in more boys, then this is the strong side for a moment, and that's the weak side. And it always goes toward the weak side and away from the strong side. So let's change it up. And the Catholic Girls' School pulls in. And so the cause is that the single girls went up. Anybody willing to show off and tell me what will happen here? Because it's very similar. Yeah, and sorry, it's Julissa, right? Okay, I thought I knew that, but I thought I would make sure. She said the couples go up because now the boys have more choice, right? But then when you make more couples, the boys go down. And so we call this shifting to the what, Julissa? Well, the whole reaction, the equilibrium shifts left or right. It shifts to the right. And, or maybe we should have said this first, but which side was the strong side when I dumped in the busload of girls? This is the strong side, and so that is the, and the system always shifts toward, always toward the weaker side, away from the strong side. But you'd already arrived at that information, so you're kind of proving my point for me that it, before we labeled it weak, you knew it correctly, it went this way, right? Do you know what I mean by strong side, weak side? You can say no. not necessarily that it has more people exactly, but the one that I made stronger, the one that I gave the side that has more of what it wants now. When the girls bus pulls up, the left side, if we can pretend it has a brain, says, yay, that's some of what I need. Single boys or girls, right? So this is empowered to do its job of making couples. But the couple side doesn't care. That doesn't change anything for the couple side. So for the next 10 minutes or something, this is the strong side and that's the weak side until it settles down and then they get to an equilibrium again. All right. So then, change it up again. The Lutheran school pulls up and they only sold tickets to couples. So the cause is the couples goes up, and that's the cause. Anybody willing to show off and tell me what you think happens? All right, you ask them. Carol, you there? You do pretty well at this class.
The boys, correct. You're asking for the boys?
I'm saying the Lutheran school pulls up and out come, oh, whatever, 20 or whatever, ticketed couples. So they come off as couples. So the couples in the gym went up. So which is the strong side and which is the weak side for the next 10 minutes or something?
The boys?
The boys is which?
The weak side.
Yeah, this is the weak side. And then somebody says, why? You didn't do anything to that side. Okay, I didn't. But how about this idea? If you dump in couples, isn't that giving this side more of what it wants or what it uses? What does this side use? Couples. How does it use them? It doesn't use them. You said we're making couples. But also I said couples are breaking up. So if you want to push this left, what do you need? Couples. Why do you need couples? Because they got to break up. Do you know what I mean? Does that make sense to you, Carol, that this is the strong side for the next 10 minutes if I dump in new couples?
Yes.
Okay, so if that's the strong and that's the weak, which way does this shift? Left or right?
Are you still asking me?
Yeah, if you would.
Okay. What's the question again? Sorry.
Which way does this equilibrium shift then? Do we get, in the end, give it 10 minutes, do we have fewer couples and more singles or fewer singles and more couples?
Fewer singles and more couples.
Let me rephrase it because that's not what I meant, but maybe the question is bad.
Oh.
The couples walk in, okay? And they went up, right?
Mm-hmm.
Okay, and that now let's say there are 60 couples because I just dumped in a new bus, right? Give it 10 minutes. And I said, as they pass through the door, we say, now there are 60 couples, just for a number, right? When I look back in 10 minutes, is it 60, more than 60, or less than 60? It's less. Because by putting in these couples, did the chances of these two making a match change? Not really.
No. Yeah.
They still have just as many choices or bad choices or good choices that they had, right?
Mm-hmm.
So this rate doesn't really change. But if I have 60 more couples with the possibility of arguing and breaking up, then this rate goes up.
Oh, okay.
Because here's another way. These couples can't form again, right? They're already couples. So they can't be like double couples.
Yeah.
So I gave this side more of what it wants, so to speak. What is it? Why does it want couples? Because that's what it has. Its reactant is its chemical is couples. What does it do? It breaks up couples, so to speak. So it's going to shift left. And also, I was trying to get everybody to recognize if I give it couples, then that's a strong side. And if that's the strong side for the next 10 minutes, then that must be the weak side for the next 10 minutes. Does that work for you, by the way? You can say no.
Yes.
Okay. And the system will shift toward the weaker side and away from the strong side. And that's on that one. So after 10 minutes, are there more, fewer, or the same single boys and girls? Carol, would you do me one more answer there?
Oh yeah. Um, More.
Yeah, more, because these break up more than these form. If I look over in 10 minutes, the number of single boys and girls on the wall staring at their shoes is going to go up. At this point, though, maybe somebody has a question like, you said the thing, but I didn't listen. It's fine. Sometimes I can't listen to, either, but like I missed it, or I just didn't understand it, or could you repeat that thing? Or what if? Questions? So that's playing with the concentration, the number of them, putting in more or fewer. Or, you know what? We could do fewer. Let's do this. The cause is the boys' school left. The number of single boys goes down. Which way does this shift? Well, does these boys leaving weaken or strengthen the left side? Weakens it. Well, if that's the weaker side for the next 10 minutes, isn't this the strong side by comparison? And the system always shifts toward the weak side and away from the strong side. Or to say it another way, if I take the bus full of the Catholic boys' school bus out of here, do the girls' chances go up or down? Down. The chances, not the numbers exactly, right? So what happens? Do the couples breaking up change? Not really. But does the couples forming change? Yes, quite a bit. So this is going to happen more than that for the next 10 minutes or whatever. So it's going to shift left. So the number of couples will go down over the next 10 minutes. And this is the part that I get some crossed eyeballs about. I'm trying to explain it really clearly, but if I don't make a big point of it, I get kids with the wrong answer. The number of single girls will go what? Up. If the couples are breaking up more than they're forming, then we're forming more single girls than we're using them up into couples. Questions or repeats from anybody? Okay, that kind of ends our concentration examples. Then we could say some other things. A dancing couple produces heat. And that actually is kind of true. So let's say that it's not a very cold night and you don't get sort of natural AC, natural cooling. So if you want the dancing couples to stay dancing and not get overheated, do you give them heat or do you turn on the air conditioning? I think I'm going to pick Gunnar. Are you there?
Yeah, I'm here.
Okay. Did you hear the question, by the way?
What? No, I didn't.
Okay, dancing couples produce heat, and that actually is true. So that's why I like this. This analogy works for a long time. So if they get overheated, they tend to break up. Does that work for you?
Yeah, that works fine.
Okay, so if you want to drive this to the right, if you want dancing couples to stay and even form more, do you give the gym heat or do you turn on the air conditioning?
You would give it heat?
So, but doesn't that make them overheat even more and then break up?
Okay, no, you would take it away. I know we did this Tuesday, so
Right. Okay. It's okay to be wrong. That's how we learn. Right. But do you know what I mean?
yeah, I get what you mean.
Okay. So we're going to take away the heat. And so if the heat goes down, this is the weak side for a moment. And that must be the strong side. And it always shifts what, toward the weak or the strong, Gunnar?
To the weak.
To the weak. So that shifts it to the right. So the number of couples will go
Up.
up. And the number of single boys and girls will go
Down.
down. And then another little phrase to maybe write on your paper or at least remember is the great thing about this unit is it is really, really clear on if you do the opposite, you get the opposite. If you do the opposite, all your answers just turn right around. If we give it heat, then that's the strong side. And that's the weak side. And the number of couples will go down. And the single boys and girls will go up. Because, also got to change this, because it went to the left. So if you understand one version, you understand the other version. If you do the opposite, you get the opposite, period. Just straight up. There is another version that we could do, though, that is a different idea, which takes maybe more concentrating than the heat part. We could talk about volume and pressure. And another note I might put on there is that volume and pressure go in opposite directions. So if the volume goes down, the pressure goes up. We talked about they're inversely related, but I know you have a lot of other classes and it's been a week or something, so you may not remember that, but they're inversely proportional. If this one goes down, that one goes up, and the other way around too, vice versa on that. So, is Lawson there?
Yeah.
Can I pick your brain on this one?
Yeah.
Okay, so then somebody spills a bunch of punch in the corner and they cut off a quarter of the gym. So the volume available, the space available to all this goes down. That means the more crammed together, the pressure goes up. Does that work for you so far?
Yeah.
Okay. Well, if I assume that the cramming together doesn't make the couples break up anymore, because I'm going to say that the couples only break up because they're in middle school and they argue or something like that, then the couples breaking up doesn't really get affected. But if you cram together the singles more, they have more opportunity to interact. So does the couple forming reaction go up or down, do you think, Lawson?
It goes up.
It goes up. Or say it a certain way, that's the strong side, but maybe I'll skip that for now. Yeah, it shifts to the right if you cram them together more. And that means the number of couples over the next 10 minutes goes
Up.
and the singles goes
Down.
down. Now that logic works, but also I will point out what I'm talking about 4 and 5. Reducing the volume, that's what I said, is basically the same thing as increasing the pressure on a gas system. That's what I said. This shifts the system to the side with the fewer gas molecules. So another way to say this is if we pretend that these are gas molecules, I have 2 gas molecules and 1 gas molecule. So the left side has 2, the right side has 1. And if I cram them together more, it will shift to the side with fewer gas molecules. Or to explain it one step deeper, if I decrease the volume, these two got to meet. Well, make them meet more and they'll react more. So this one, the side with more gas molecules needs cramming together to make connections more than the side that has fewer gas molecules. And so we can turn this around. And I said, if you do the opposite, you get the opposite. So then we reopen the whole gym and the volume goes up, the space goes up, which means the pressure, the cramming together goes down. And is Kendall here? Kendall? How about Annalee?
I'm here.
Can I get you to give me a couple answers here or try?
Sure.
It's not a quiz. No, remember, if you're wrong, it's no pressure. If the volume goes up, the boys and girls meet more or less?
They meet more.
No, I mean, if we expand the available space in the gym to the kids, so the space goes up and everybody can spread out more. So do they meet more or less?
They'll meet less.
Right. And so do they form couples better or worse?
Worse.
Right. So the rate of forming couples goes up or down?
Down.
Okay, good. The rate of couples breaking up, though, should be unaffected because that doesn't really depend on how crammed together they are. So which one is stronger for the next 10 minutes, breaking up or forming couples?
Forming couples?
No, I was saying that if they meet, we were saying, you and I, saying that if they meet less, then they don't form couples very well, right? As well?
Mm-hmm.
But you know what? Now I've got myself twisted. I kind of forget what I asked. So I'm going to give you a break. The forming goes down, the breaking up stays the same. So which one's stronger?
The breaking up.
The breaking up. So this shifts left or right. Which way do I draw this arrow?
Shifts left.
Yeah, it shifts left. Which means the number of couples over the next 10 minutes goes
Down.
down. You know, also the heat would go what?
Down.
Down. And the singles goes
Up.
Yep. Because we could say this is the weak side and that's the strong side if we're going to increase the volume or decrease the pressure. Same thing, basically. Okay, good job. And every time I explain this, I get a little faster. So I think that is basically my example there. So I'm going to say, let's try. Yep. Yep.
So I think it was last week when we started it for the simulation. Are we supposed to finish that?
Just finish the right. The simulation, I made a video and I got to put it up, and then I also changed the due date so that it's not unfair. So yes, finish it on your own, but there's not a lot more to it, and I'll put up the video in which I went over it. Okay. So I think we are at, let's try some of this. I'm talking about this one. Also, I put up 4 suggested YouTube videos for anybody who wants to listen to somebody who's not me. You can just click them out of the digital document. So for number 1, which change would cause the equilibrium to shift to the right? We decrease the concentration of dihydrogen sulfide. And I know it's been a while since we did the naming, but this is the only one with hydrogen and sulfur in it. So if this goes down, we pull some of these out by magic. The left side is now weak or strong for the next minute. Weak. And it always flows toward the weaker side and away from the strong side. So this is going to go shift left. So does it shift to the right? No. Increase the pressure. Increase the pressure crams everything together more. And that would go toward the side with fewer gas molecules. First of all, let's count the gas molecules. Is it gas, 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 gas? That's what the G is. Yes, so I have 3 gas molecules and 5 gas molecules. So which one needs cramming together more? The 5 molecule side or the 3? The 5 needs it more than the 3. It's harder to make 5 matches than 3 matches. So this is the strong side for a moment, and then that's the weak side. Or increasing the volume. I need this one. Reducing the volume is basically the same thing as increasing the pressure, which is the way that this said it. It shifts to the side with fewer gas molecules. But also we could say, one more time, that if you cram systems together, the side with more gas molecules needs it more than the side with fewer gas molecules. So then the 5 gas molecule side is stronger than the side with 3 gas molecules. And that's the weak side, and that's the strong side. And so it will shift left. And so the answer is no, it doesn't shift it right. On C, increase the concentration of carbon disulfide. Well, that's the only one with carbon and sulfur in it. So if that goes up, the right side is the strong side or the weak side for the next minute. Strong side. But it always flows toward the weak side. So this goes left. So no, it does not shift it to the right. Decrease the concentration of methane. And then somebody says, I don't know what methane is. Well, I know, but we know that's hydrogen, and we just named these 2. So it must be that one. And if this goes down, then the left side is the strong or the weak side. Which? Weak, because I just reduced what it needs to do its job. And the system always flows toward the weak side, so this goes left, and so no, it does not make it go right. So at this point, I feel I probably should get a question about what if, or I missed that part, or can you just repeat letter C or something? On to gas, gas, gas. All right. Actually, that doesn't matter because we don't do any pressure or volumes. Sulfur dioxide is added to the system. Sulfur that's a 2, oxide is added. If you add something on the right side, then the right side is the strong side, but it always shifts away from the strong side, so the system shifts left. Sulfur trioxide is added. It's added on the left, and the left side is the strong side. But it always flows toward the weak side, so the system goes right. Oxygen is added. That's added to the right, so the right side is the strong side, but the system always shifts away from the strong side, so it goes left. And questions? Repeats? How about a few more? And I did post the solutions, and I'm begging you for questions. I promise that when I say and try the rest, that's not so I can just, not get bothered. It's that when I had math classes in high school, that lady talked for basically the whole period, and I couldn't listen the whole period. My brain just turned off for math. And I really think if she talked for half the time and let me try it for half the time, I would have paid a lot more attention, because I was just teaching myself out of the book at home, basically, because I wasn't listening in class anymore. So please ask questions, though, when you try it on your own. But how about we do a couple more? On 3, HCO is added to the system. Well, if you give something more on the left, then that's the strong side, but it always shifts away from the strong side, so it goes right. The pressure increases. Now, this one, it has a bit of almost a trick to it here. That's not a gas, and that's not a gas. Solid liquid. So my gas count is 0 gas and 1 gas. Because if you think everything is gases, you'll get 2 and 2, and then the pressure doesn't matter because it's equal gas, but it's not equal gas. So if the pressure on the system increases, the left side doesn't care because it has no gas. The right side has a gas molecule, and before you say, but only one, that doesn't matter. But if you cram the oxygen next to the liquid even more, then it can react better. So then this is the strong side, and that's the weak side, and it always goes toward the weak side. So it will go left. On 4, volume is increased. So volume goes increase and pressure goes down, in case that helps. And are they gases? 1, 2, 3, 4. Yes, they're all gases. So how many gas do we have? 5 gas and 4 gas. And if the pressure goes down, yes, the pressure goes down, they're crammed together less. Or to say it another way, the volume goes up. Okay, which one is trying to fill more volume, a greater space? The side with more gas molecules, which is that one. So the left side with more gas molecules says, yay, more space, and the system shifts left. Now, somebody says, but the 4 is trying to fill it too. Yes, but the 5 is trying to do it more than the 4. It's trying to fill more space, more than 4 gas molecules is. Or, to explain it all the way around another way, remember when I said if you cram them together tighter, the side with more gas molecules needs it more. But I also said, if you do the opposite, you get the opposite. So let's uncram them. Which one did you harm more? The side with more gas molecules or fewer? More. You harmed it more by not cramming them together if the volume goes up. So I harmed the more gas molecules side more, which means it's the weak side for the next minute or whatever. And the system always goes toward the weak side. Okay, got a big nod out of Julissa. I knew she was paying close attention there. Good. How did you get the number of gases? These are all gases, and I have 4 molecules of gas plus 1 is 5. 2 molecules of gas plus 2 molecules of gas is 4. Does that work, Carol? Oh, okay. Well, how about 5? Predict the effect of decreasing the volume. So decreasing the volume is the opposite of number 4. If you do the opposite, you get the opposite. So instead of shifting to the side with more gas molecules, it should shift to the side with fewer. So gas, 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 gas. So this is a 3 gas molecule, and that's a 4. If you cram them together less, well, which side is trying to fill more space? The greater molecule, gas molecule side. So this should go right. And so then that repeats again. We just need the count. This is gas. Oh, that's a solid. Ooh, trick question. That's a 4 gas then, and that's a 3. And we said it goes toward the more because we're leaving more room, and the more gas molecules wants to fill more room more than the other side does. On C also, this genuinely does become kind of a trick question because if you don't notice that the carbon is a solid, you get 2 and 2. So I have a 2 and a 1. And we said it's going to go toward the side with more gas molecules. And I just thought I might need to go check my solutions. My solution, I think, is wrong. I need to check that one. Decrease the volume. So, no, that's right. Okay. So, should I go over one with somebody or go back? Or I can take a request if you're looking ahead and think that looks weird, or I don't understand the question or something. I can just take a request and do 9 or something. Because again, trying not to talk all the time and trying to shut up and let people think, I'm out of new ideas is my point. So I'm at the point of, should I do one for you or explain something back or explain one of these rules or what? 11? Alyssa says 11. Increase. Oh yeah, actually that's a good point. Increasing the temperature on the position of, all right. So I'm glad you said that because I need to point this out. Exothermic reactions have a negative delta H value. And the heat goes on the right. And then the opposite. Endothermic have a positive delta H and the heat goes on the left. So what we mean by a negative value here is that these chemicals lost heat, lost energy. So from the perspective of the chemicals, if they have tiny brains, that's a negative number to them. So if the energy, the heat escaped, then it is a product. And I probably should have put more room there. That's supposed to say plus heat. Or maybe we can just put it here, plus heat. So the heat is released. And so it was produced. So if we increase the temperature though, and heat is, in all three cases, a product, which side got stronger, the right side or the left? The right side, because the heat is on the right. But so the right side is the strong side, but we said it always goes away from the strong side. So in all three cases, increasing the temperature is gonna make it go backward. Or I think it was Jacob talking before about computer chips. Computer chips run and run and run, and the heat comes out. Well, to make it run better, do you feed it heat or do you remove heat? Remove it. So if you give it heat, it runs, that's opposite. The computer chip, in a sense, runs backward, it runs slower. If you want this to work better, you remove heat if it's producing heat.